Hello, welcome to this demo where I demonstrate the neural network that we created in order to recognize different cars from different makes and models. Um, this is a short demo about what we discussed earlier in the conference call on last Tuesday, but since the audio was in a different call, it was on the telephone, the screencast that I made did not record the audio, so that's why I recreated this little demo to give you a demonstration of what we talked about earlier. So let me switch to the environment where we created our testing environment or our demonstration. What we have here is a neural network that we trained to recognize different car models from different makes and different manufacturers. As we demonstrated earlier, we have here on the left, we have 4 different cars. We took the Volkswagen Golf and the Volvo V40. From both models, we took 2 different years of manufacturing to make it a little bit challenging for the model to recognize the subtle differences between those models. So what we did is we added for each category, for each tag, we added numerous images. The number of images that we use to train the model is depicted between the brackets. So we uploaded for every model around 100 images to train the model. So if we have a look at the kind of images that we used to train the model, if we have a look at the Volkswagen Golf GTD 2014, for example, and we scroll through the images, you see that we used all sorts of different images from all different angles from the car, different colors, different situations. The more images and the more the images differ from each other, and the more the differences and real-life scenario situations the images depict, it's better. Because the more you have and the more different situations you have, that will make the model smarter, and it will be able to learn much faster to recognize a certain car. So once you uploaded enough images to train the model, you can train the model. And in this case, yeah, like I said earlier, we used around 100 images. But in theory, around 30 images should already be enough to give the model a basic understanding of the car. But as I said earlier, the more the better, and the more situations the better, because it gives the model an understanding of what it can encounter in real life, in real world. So in this case, I trained the model already, and now we can use it. We can throw some images at it and see what it what it finds. So let's take the Volvo V40 from 2013, for example. If we would take this this car, I can select it, and we can see what the model thinks. So in this case, it gives you a classification or a probability percentage from each category with the likelihood that it thinks to what category the image belongs. In this case, I took the Volvo V40 for 2013, and it's 99% certain that the image that we used, that it is a Volvo V40 2013. So in this case, the model was correct. You also see some percentages small percentages in the other categories, because it finds, for some reason, it finds some similarities in those categories as well. But in this case, it's very confident that it is a Volvo V40 2013. So let's take another one, for example. It's also V40 2013, but different color, different situation. And again, the model is pretty certain, even more certain, 99.9%, that it is a V40 from the year 2013. But it can also be mistaken from time to time, or in this case, let's take the image from the front of the car, and then in this, we will see that the model is wrong. It thinks that this is a car from a V40 from 2017, but actually it is 2013. So in this case, the model is wrong, and this can be explained to some extent, because if we would have take a look at what kind of images we used for the Volvo V40 2013, we will see that most of the images are from the side of the car and not from the front of the car. So compared to all the images that we used, there are only a few images where the car is taken straight from in front of the car, so that you would not see, like this picture, it is a picture from the front of the car, but all the other pictures show more elements of the car. So that's why the model simply has not enough information yet to recognize this car from only the front. So let's have test some more images, different, test the Golf, for example. Let's take the Golf GTD 2014. Here it's the same story. Let's take this one. It's from the side, and it's very certain, 99.9%, that it is a Golf GTD 2014, which is correct. And here also, if we would take the other one from, or this one from the front, for example, we will see similar behavior as we saw with the V40. It simply does not have enough reference data yet to recognize the car only from the front. Let's take the Golf GTD 2017, because we now tested the 2014, but let's have a look at the 2017 as well. Well, here it is pretty certain that it is a Golf GTD 2017, and this is actually a nice image to what would be a possible real-life scenario, because it is the car is sitting in on a parking lot. There are other cars behind it, there are people behind it, and still it does recognize with a very high probability that it is a Golf GTD 2017. So this is a clear example of how it would work in real life. Let's take another one, last one. This one, for example. Let's see what it finds. Well, here you can see that it is still pretty confident that it is a Golf GTD, but it also, to some extent, finds it some references in the Volvo V40. But still, with a high probability, it is a Golf GTD from 2017, which is correct. So now that we tested the model with different images, and we saw in the results that it was, in most situations, it was able to make the right prediction and make the right classification. but in some cases it was wrong, and we can give feedback to the model so that next time it would encounter an image in the same situation, it would make a better prediction. And that's done by giving feedback to the model, because here you can see all the images that we used to test the model with the predictions that it made. And if we would take the Volvo V40 2013, the one from the front, where it was mistaken, it thought it was from 2017, but it's actually from 2013. And here we can give feedback to the model and say, well, hey, here you were incorrect. It should be this category. And we can save and close it. And next time, if we would train the model, then it has more information to how to categorize this image. And let me have a look. I believe it was wrong in this case as well, but also from the front. It was 2017, but it is 2014. You can say, hey, that should be this one and not the one that you thought it was. Save and close it, and then the image disappears and it becomes training material for the model. So if a user or an end user would upload a picture of their car and the model made an incorrect prediction, it could end up here in a similar environment like this, and then we can give feedback to the model. Well, hey, this was not the car that you thought, it was actually this car. And then the next time it encounters a similar images or a similar car, then it will give the right or more correct prediction. So this was the demonstration. I hope it clarifies and shows everything that we talked about on the conference call from last Tuesday. If you have any more questions, don't hesitate to email Mario or me. He already shared my contact details with you guys, so don't hesitate to contact me. Thank you. Bye-bye.